Imagine a computer that could check every possible solution to a problem simultaneously, not one after another, not just really fast. Simultaneously. Sounds like science fiction? Well, welcome to quantum computing, where physics decided to throw logic out the window and start breaking every rule we thought was sacred. Hey everyone, today you're going to learn about technology that sounds like it was invented by someone who had way too much coffee and an even bigger imagination. By the end of this video, you'll understand what quantum computers actually are, why they're going to change absolutely everything, and most importantly, you'll realize this isn't some distant future fantasy. This is happening right now. And yes, there's going to be a lot of sarcasm, because honestly, there's no other way to talk about things that can be turned on and off at the same time. Let's start with something you already know. Your laptop, your phone, even your smart refrigerator that for some unexplainable reason needs to be connected to the internet. All of these devices work with bits. A bit is the fundamental unit of information that can be either 0 or 1, on or off, yes or no, exists or doesn't exist. It's like a light switch. Either the light is on or it's off. There's no room for nuance, emotions, or existential crises here. 0 or 1, period. Your computer processes billions of these boring black and white decisions every single second. And to be completely honest, it does a pretty good job. Thanks to these simple zeros and ones, you can watch cats on YouTube, scroll through social media at 3 in the morning instead of sleeping, and pretend you're working during Zoom calls. Classical computers are like really fast, really obedient idiots. They do exactly what you tell them, but only one thing at a time. Even when it seems like your computer is multitasking, it's actually just jumping between tasks so quickly that your brain gets fooled into thinking it's doing everything at once. Now buckle up, because we're about to collectively lose our grip on reality. Quantum computers don't use bits. They use qubits, quantum bits. And this is where the magic begins, or what physicists call superposition, which is basically a fancy way of saying this thing can be 0 and 1 at the same time. Yes, you heard that right. Not either or. Not rapidly switching between the two. Simultaneously. It's like your refrigerator being both open and closed at the same time until you look at it. Which, to be completely honest, perfectly describes my relationship with my diet. Imagine you have a coin, a normal coin. When you flip it, while it's spinning in the air, it's neither heads nor tails. It's just spinning. But when it lands, it's either heads or tails. End of story. A qubit is like a magical coin that never lands. It keeps spinning forever, being both heads and tails at the same time, until someone looks at it. And when you look, bam, it has to choose a side. The physicists who discovered this were just as confused as you are right now. Albert Einstein hated this idea so much that he called it spooky action at a distance. Einstein, the guy who came up with the theory of relativity, looked at quantum mechanics and said, "No, this is too weird even for me." That should tell you everything you need to know. You thought superposition was weird? Hold my quantum beer, because now I'm going to tell you about quantum entanglement. Take 2 qubits and entangle them. Not physically, quantumly. What does that mean? It means these 2 qubits become so connected that no matter how far apart they are, even if they're on opposite sides of the universe, changing the state of one instantly affects the other. Faster than light. Faster than anything. This is the moment when Einstein completely lost his patience and said that God does not play dice. Unfortunately for Einstein, experiments proved that not only does God play dice, but he's playing them at multiple tables simultaneously, in different dimensions, and winning every single time. Think of it like magical socks. You have a pair of socks that you throw into the washing machine. One flies into your drawer. The other mysteriously disappears somewhere in the universe. But they're entangled. So if you look at the one in your drawer and see that it's blue, you instantly know that the other one, wherever it is also blue. Not because they were always blue. They didn't have a color until you looked. But the moment you checked one, the other made the same decision. Scientists hate this analogy, but honestly, they hate all analogies because none of them fully capture this absurdity. And that's exactly what makes it beautiful. Okay, so we have computers that use things that exist in two states simultaneously, connected in magical ways across the universe. Great. So what? Everything. That's what. Your classical computer, to solve a complex problem, has to check every possibility one by one. If you have a problem with 1,000 possible solutions, the computer checks solution 1, doesn't work. Solution 2, doesn't work. Solution 3, maybe, and so on. It's like looking for your keys by checking every pocket one at a time, methodically, slowly, while you're already late for work. A quantum computer? It checks all possibilities simultaneously, because qubits exist in superposition. Instead of checking 1,000 solutions one after another, it checks all of them at the same time. This isn't even an unfair advantage. This is cheating on a cosmic level. A classical computer needs more time to solve a problem as the number of possibilities increases. A quantum computer? The more possibilities there are, the more it shows off by solving everything in one instant. Imagine a maze. A classical computer sends one person who tries every path one by one, goes back, tries the next one. A quantum computer? It sends 1,000,000 versions of that person simultaneously, each trying a different path. And then, somehow, all those versions come back together and tell you which path leads to the exit. Don't ask how. Even physicists just shrug and say, well, that's just how it works. All right, enough theory. Let me show you where these quantum weirdnesses will actually change your life. First up, medicine. Simulating molecules and discovering new drugs is a problem so complex that classical computers could spend thousands of years on it. A quantum computer can do it in hours. That disease we've been looking for a cure for decades. A quantum computer can analyze billions of possible molecular structures simultaneously and find exactly what we're looking for. This isn't maybe someday. Pharmaceutical companies are already using this technology right now. Second, cryptography. All your online privacy, every password, bank security, it all relies on encryption that's hard for classical computers to crack. They'd need billions of years to break good encryption. A quantum computer could do it before lunch. Yes, that's a problem, but it's also the solution, because we can create quantum encryption that's unbreakable, even by quantum computers. The arms race between hackers and security just entered a completely new level. Third, artificial intelligence. AI needs to analyze massive amounts of data and learn from it. Quantum computers can exponentially speed up this process. Your voice assistant that understands you reasonably well now? Imagine a version that actually gets you. Self-driving cars that are uncertain right now? With quantum computers, they'll become so intelligent, they'll be safer than you behind the wheel after a full day of scrolling TikTok. Fourth, finance. Portfolio optimization, market prediction, risk management. All of this requires analyzing enormous numbers of variables simultaneously. Quantum computers love this stuff. Wall Street is already investing billions in this technology. Yes, the rich will get richer, but at least they'll be using cool technology to do it. And finally, climate change. Climate modeling is one of the most complex problems in the world. You have to account for oceans, atmosphere, forests, humans, millions of variables all affecting each other. Classical computers do what they can. Quantum computers can do it thousands of times more accurately, helping us truly understand what's happening to our planet and how to fix it before it's too late. Hopefully. Now for the bad news. Because of course there has to be bad news. Quantum computers are incredibly fragile. Qubits need to be kept at temperatures close to absolute zero. That's minus 273 degrees Celsius. Colder than space. Colder than your ex's heart. Why? Because any heat, vibrations, or electromagnetic interference destroys the superposition. The qubits lose their quantum power and become just regular bits. All the magic vanishes. This is called decoherence, and it's the biggest enemy of quantum computers. Imagine trying to build a house of cards during an earthquake. Now imagine that earthquake is coming from a single atom that vibrated 3 kilometers away. That's the level of delicacy we're talking about. On top of that, qubits make mistakes. Lots of mistakes. Way more than classical bits. So scientists had to invent something called quantum error correction, which is so complicated that you need dozens of physical qubits to create one reliable logical qubit. It's like hiring 10 interns so that one of them does the job correctly. And finally, quantum computers aren't better at everything. They're good at specific, highly complex problems. You're not going to use a quantum computer to browse the internet or write an email. Classical computers are perfectly fine for that. Quantum computers are like specialized tools, incredible at what they were designed for, but useless for everyday tasks. All right, let's wrap up this quantum madness. Quantum computers use qubits that can be both 0 and 1 at the same time, thanks to superposition. They can also be entangled, which lets them communicate instantaneously regardless of distance. This sounds like complete fantasy, but it's real physics, proven in laboratories around the world. Thanks to these properties, quantum computers can solve problems that are impossible for classical computers: medicine, cryptography, artificial intelligence, finance, climate. All of this is being revolutionized. Not in 100 years. Now, companies like Google, IBM, and Microsoft are already building and perfecting these machines. Yes, there are challenges. They're incredibly delicate, expensive, and complicated. But also, remember that the first computers took up entire rooms, needed air conditioning the size of a house, and had the computing power of a calculator. And now you carry a computer thousands of times more powerful in your pocket. The history of technology shows us one thing. What seems impossible today becomes normal tomorrow. Quantum computers sound like science fiction because we're living in the moment when science fiction becomes reality. And honestly, that's incredibly exciting. Thanks for watching. If your brain is now trying to exist in a superposition of understanding and complete confusion, that means you got it. Welcome to the future. It's weird, but it's going to be amazing.